Good evening, everyone, for yet another webinar from Mathrevolution. And this is one of the most important webinar that I'm be conducting today, which says fatal mistakes to avoid in GMAT. I mean, every aspirant has been well acclaimed with what do we learn into GMAT Quant. And, we go through a lot of topics, be it statistics, geometry, number properties, and everything. And one key factor into it is if the answer is wrong, it's over. It's game over, no matter whatever the mistake or error that we have made. So that is one of the prominent error that we make and wherein we lose the marks. But what are the other things? Maybe some traps, maybe anything that can count to make us or force us to do a fatal mistake. That is all what I'm going to talk about in today's webinar. Any solution that is taking more amount of your time to solve it will also be considered as a fatal mistakes in my experience, because if you take 4 minutes to 5 minutes to solve a question, and if it is taking more than, if it is eating up 2 minutes extra for the questions, it may give you a hard time at the end of the exam. So be it a comprehension, be it a lengthy solutions, be it a conventional approaches, anything, that is all that I count into the fatal mistakes. So once we go ahead with this, the first thing is never ever combine the PS and the DS questions. We have this habit of solving a lot of MCQs and the PS questions, and at times we have this habit of applying the same sort of a strategy to solve the DS questions, and we end up making an error. So this is one of the fatal error that we always make. So always be very pretty sure about it. In PS question, you have to find an answer out of 5 choices, whereas in DS question, you just have to determine whether the information is relevant and sufficient enough to answer the question, either in terms of yes or a no, or maybe like a question which says what is the value of X or something. So now understand, in this fashion, you don't have to solve it. You just have to know whether you will be able to solve that equation, right? So this is the first mistake that I have experienced with a student does. Let's quickly see one of the questions on the basis of this. And choose E when you encounter the difficult DS questions. That is again one of the key method that you could apply. Let's go with one of the DS questions on the screen, which will ask you to calculate the value of X, and there would be two polynomials given into the two statements, which looks not that scary, but yes, we feel like how to solve this. It says like x cube plus 2x square plus 2x plus 1 is equal to 0, and the second polynomial says x to the power 5, then x to the power 4, and x and 1. So in this particular question, if I have to talk about, we have to find the value of x, but you don't have been given, or you have not been provided with 5 options wherein you have to find the exact value of X. So this is not a PS question, it's a relevant DS questions, and wherein you have to get to know whether you would be able to find the value of X from either of these statements, or maybe combining both statements, or from, you may not be able to find the value from both. So therein where we have to be very short, precise, and consolidated on solving a DS and a PS question. So right now, I'm going to solve this question through variable approach. The reason behind that is conventional approach will take a lot of your time, and that is also a mistake, because if you're not able to save your time, you would end up at the score of 47, 48, because you have to rush at the end. So right now, according to the variable approach, if I see there is only one variable involved in this, which is X, and to match up the numbers of variable with the equations, I just need one equation, which is pretty available from either of the statement first and second. So in this scenario, the answer should be, or the most likely answer should be D. So this is how the variable approach looks like. If you want to get into the details of it, you can often visit to mathrevolution.com, check it out on the lessons, the variable approach, and you would be able to understand it properly. Moving ahead with the solution, if condition number 1, if I take x square common from the first two factor, I'm left out with x plus 1. And then at the end, I can make it as x plus 1 whole square, so that I end up getting an answer of x is equals to -1. And when we solve a lot of equations, you can also try putting in some values for x, like, you cannot put x equals to 0 because at the end the equation would be 1. So if you're putting x equals to 0 in this, we're still getting 1. So x should be minus 1 so that, the equation gives you 0. So solving condition number 1 gets you x equals to minus 1. So that is pretty sufficient because you're just getting one answer for it. So number of answers should also be 1 if they're asking the unique value to find it out. If we proceed with the second equation that says x to the power 5, I'll take x to the power 4 common out of it so that I'm left out with x to the power 4, x plus 1 plus x plus 1. Taking x plus 1 common, I'm left out with x to the power 4 plus 1 equals to 0. Now, I know that x to the power 4 plus 1 would be greater than 0, and hence my x plus 1 should be equals to 0, so that the product of two factor is 0. And ultimately, I get x equals to minus 1. So what I get here is a tip that, if your condition number 1 and condition number 2 gives you the same values, then 90% or 95% your answer would be D. But in this particular specific question, there were two things that I wanted to talk about. Avoid your habit of PS solution into DS, and second, go for a variable approach solution or a cut short methods. Don't ever try going for a conventional methods to avoid the time lengthies. Let's go for something which is pretty important. I'll be talking about some key questions and how to solve those through the variable approach right now to save the time. So first is common mistake type C1. So there are three steps that is involved in the variable approach. First is to modify and recheck. There are a lot of questions in the topics like inequalities, ranges, and absolute values, and some system of linear equations wherein you can definitely modify. And it has been noticed that once you modify it properly, you end up either directly getting to one of the conditions as an answer. So pay attention more to modify the situation rather than jumping on the solution. Second step is check the number of variables and equations and then make up that how many equations more are required to solve the questions, and accordingly you can mark your answer as A, B, C, D, or E. So if we go about common mistake type 1 and common mistake type 2, it will appear in all the DS questions definitely, and it's very basic. The major important thing that you have to remember is that answer is always 1. So if you're getting yes and a no at the same time, that is a maybe situation. But if you're getting no, no, if you're getting yes, yes, it is an answer. And no is still an answer. So, if a question asks, is x greater than y? And if you can answer it, no, x is not greater than y, then that is sufficient to answer. So no is also considered to be an answer. That is a CMT1. That's a common mistake type 1. Common mistake type 2 says that if a question is asking for a close-end values of x or any variable, then there is only one answer that exists. So if in this particular question, which is about to come on the screen, that says, is x greater than 0? So when I say is x greater than 0, that means my answer should be in terms of either a yes or a no. It cannot be maybe. So is x greater than 0? And I have been given two statements, x equals to minus 1 and x equals to 1. So common mistake type 1 says that, there has to be a yes or a no uniquely. So, if there happens to be yes and a no at the same moment, it cannot be the answer. So x equals to minus 1, is that greater than 0? No, it's pretty sufficient for me to answer. So this is unique. When I say x equals to 1, is that greater than 0? Yes. So this has been taken so easily to make you understand that, how does the CMT1 gets applied on this part. So our answer goes for this question as, so condition 1, the answer is no. So that's a unique. Condition 1 alone would be sufficient. Condition number 2, that says x equals to 1. Our answer is yes to the question is x greater than 0. And hence, condition number 2 alone is also sufficient. So D is the correct answer. Post webinar, once this particular video gets uploaded, I would request you to go and try solving the DS question through the conventional approach and make a note of the time you take to solve it, and then try it with the variable approach and you will see the difference. Okay, let's go on to the CMT2, which is a common mistake type 2. And now in this particular set of question, we have to be looking for a unique value for a particular variable. For yes and no, we are already done. That is CMT1. For CMT2, we will be definitely looking for a variable value. So the question right now says, what is the value of R? Now R equals to what? And we have to solve it in reference to the two statements that is given. R cube minus R square minus 6R equals to 0. And R is equals to minus 2R. If I solve condition number 1, if I take an R common, I'll be left out with a quadratic equation or a quadratic polynomial, that is R square minus R minus 6. Now either R equals to 0 or either R square minus R minus 6 equals to 0. If I put the quadratic part to the 0, I need two numbers that get multiplied to get me minus 6, and the sum should be minus 1. Factorizing the quadratic equation, I end up getting it as R minus 3 and R plus 2. So overall, the values that I get here is R is equals to either 0 or 3 or minus 2. But again, if I ask what is the value of R, there is not a unique answer. This particular condition will not be sufficient. If I go ahead and solve the condition number 2, which is R is equals to minus 2R, and if I just rearrange it to get me R plus 2R equals to 0, that makes 3R equals to 0, post which it gets me R equals to 0. So this is definitely only possible when R equals to 0. So in this particular condition, I get a unique answer. So hence this becomes sufficient. The condition number 1 is giving me 3 values, and that is not unique. So the condition number 1 alone is not sufficient. Condition number 2 gets me only one value, and hence it is pretty sufficient to answer the question or to get me the value of R equals to 0. And my answer goes is B is the correct answer for this. All right, let's move ahead with the next part, how to distinguish between CMT1 and CMT2. We'll be very quick on this particular question now, as we have been already known to what we have to find. Question says, is x is equals to 0? Is x equals to 0? Question is, it's starting with the word is. So if it is, your answer should be yes or a no. So this is a CMT1 question. Is x equals to 0? Condition number 1 says x is equals to minus 1. Your answer goes no. This is unique answer. This is sufficient. Condition number 2 says x is equals to minus 1 and x is equals to 1. So for both the values of x, be it a minus 1 or 1, it is not equals to 0, and you're getting a unique no in both the situation. If in case it was minus 1 comma 0 and one of the answer was no and one of the answer was yes, we could not have been lead to a situation or a decision wherein the answer would be sufficient. But in this case, this is a sufficient answer. So condition number 1 that gives us a no answer to our question is x equals to 0. And condition number 2 gives us again a no answer with a unique no. We get it as sufficient. So now condition 1 and 2. And see, I'm telling it to you right now, trust my words, right now this question may look very easy, but under the the exam pressure, and there are a lot of other parameters that add up within the exam. It's not only the knowledge. I know the concepts, the knowledge, the skills, your hard work would always be there to showcase, but every other parameter would count a lot during your exam of 3.5 hours. So again, looking at this particular question and jumping onto a solution, therein where you have to hold your nerves, and that would only make a difference of 50 to 48 and 48 to 46. That is the only difference, because if you're able to crack it to 48, why can't 50? So go slow, learn the approaches, that is gonna save you a lot of time. Okay, let's go on the question number 2. X is what? Now, this question is asking us X is what? So if X is what, then I need a unique value for it. So my condition number 1 says that X is equals to minus 1. That is sufficient. But my condition number 2 says X is equals to minus 1 and 1. So I'm still undecisive about the fact that what is X. So this will not be sufficient. So again, CMT2 applied. Condition number 1, it's a unique answer, so that is sufficient. And condition number two, x equals to minus 1 comma 1, that is a not unique answer, so hence it is not sufficient. The answer goes as A. Now, common mistake type 3, when we talk about the common mistake type 3, soon I'm about to come to some typical key questions, so please remain very focused on this. So common mistake type 3, again, the three steps are same. We have to modify, we have to recheck. That's the first. We have to match the number of variables and equations in the third step. Before that, we check the number of variables and equations in the second step. So what does CMT3 and CMT4 talks about? Now, always remember integers, statistics, probability, inequality, and absolute value. If these are the questions that you're getting in, plus at least two variables, your most likely answer goes to be C, but that often changes at the end. Condition number one and condition number two are independent. Map this particular thought in your mind properly, because I've seen a student taking a conclusion from condition number one and applying in a second statement also while solving it as an independent. So when you check answer B separately, there is nothing called A. If you're checking A, there is nothing called B. But I have seen instances wherein people often make, and this always happens when you rush, and and that is pretty okay to happen with anyone, so it doesn't count on to your knowledge skills. There's some small parts that has to be taken care of to score better. So let's go with a question right now for a DS. If A and B are positive integers, what is the value of B? The question will be there on the screen in a minute. It's there. If A and B are positive integers, what is the value of B? Now, see, understand they're asking us the value of B here. A and B, they're the positive integers, so they cannot be zero. They have to start with ahead. Now, we have been given two conditions here. 2 to the power a, 7 to the power b is 1372. And second statement says that a is equals to 2. Now, I'll soon jump with the fact that, a cannot be, the second condition cannot be the answer, because they're asking for b and it says a is equals to 2. So my mind will definitely say, what about b? It doesn't give me the value of b. So 2 cannot be the answer. And I make a decision like, Q cannot be the answer, that means B cannot be the answer, so D can never ever be answer. So either it has to be A or C, and if that doesn't work, I'm definitely marking it as an E. But I have to find a unique value of B that has to be taken care of. It's not only about finding a value of B, it's about finding a unique value of B. So, I have got two variables and possibly I should go for answer is C. Now, condition number one, it says 2 to the power a 7b 1372. Condition 2 says a is equals to 2. I'll simply put a equals to 2. I'll combine both the situations. And it says 2 square 7 to the power b is equals to 1372. 2 square makes it 4. I'll divide both the sides by 4. So, I'll be left out with 7 to the power b is equals to 343. 343 itself is a power of 7, so I can write it as 7 cubed. So b ends up at 3. So now what I got here is that my answer is C, because when I combined both the situation, because how would I do it? I need at least one variable, right? So it's C, the particular plot has been, or the trap has been already there in the question itself. 2 to the power a, 7 to the power b, 1372. There are two numbers, 2 and 7 raised to a power a and b. You have to find the value of b, and they're already giving you a value of a in the second condition. So it looks like if I put that a equals to 2 in the first, that is already solved. I'm just left out with one variable, which is raised to the power of 7. Luckily, I'm ending up at getting 343, which is also can be expressed properly in the terms of 7th power. I'm ending up this as an answer at C, and I'll mark it an answer as C. But since it is an integer question, it is a key question. The only mistake that I did, why didn't I check the condition number A or condition number 1 alone? So, this is what a CMT4A apply, that if you're getting your answer as C very easily, when you read these words like integers, please stop yourself marking an answer as C there would directly a plot or a trap. Go on conditions individually and check for those. Let's check each condition separately and see what happens next. 2 to the power a, 7 to the power b is equals to 1372. Let's prime factorize 1372 and we end up getting it as 4 times 343, which could again be factorized at 2 squared times 343. 343 can be written as 7 cubed. 4 is written as 2 squared. So this whole expression can be written as 2 to the power 2 and 7 to the power 3, which on the left-hand side, if I compare it with 2 to the power a and 7 to the power b, I end up getting it as a equals to 2 and b equals to 3. This condition was sufficient enough to get me the value of b. But I rushed because I have only one thing in my mind. I'm dealing with two variables, A and B. If one of the variable is given, second can be easily found. So my answer should go as C, but this was the biggest trap. And these are the mistakes that a student always does, just looking at the options to solve this. So always make sure, you know, once you go back to this video, pay attention to this question again. In condition number 2, if you check, these are still unknown, so that cannot be answered. So now we're getting two answers here, C and A, right? But I'll mark it as A because it's a key question. Integers, statistics, probability, absolute values, and inequality. Pay attention to these questions. Let's go on to CMT4A, which talks the same. If you're getting A as easily as your answer, if you're getting C as your answer very easily, you have to choose for A and B. And if you're getting A and B very easily, you have to choose for D. So these are the two cases. Case A says, if you get C as your answer too easily, consider A or B as an answer. And case B says, if you are considering A or B as your answer easily, choose D as an answer. People who are learning variable approach or have learned would be able to make out this very quick, and this will definitely help you saving a lot of your time in the question. It is not at all necessary for every question to start checking from A, then B, then C, then D or E. So always make sure that you save your time in checking your answers. CMT4A, again I repeat, there could be possibility that you're getting your answer as C and A, mark C, or C and B, mark B. If it's an integer question or statistics or probability, inequalities, or absolute values. That is what CMT4A says. So let's talk about one of the questions here. If x and y are integers, is xy an even number? Question is asking about, is xy an even number? Answer should be a unique yes or a unique no. And question is, if x and y are integers, again, it's a key question. We have to pay attention to CAB. So x is an even number, y is an odd number. All right, let's talk about this. Now, if you go ahead, we have two variables, x and y, and we need two equations. Definitely the most likely answer goes as C. If I combine both the situation, xy an even number, when I can get the product as an even, definitely one of them has to be even. That is what my situation says. X is even, y is odd, even times odd, that is an even number. So I'll definitely jump to mark answer as C, but again, it's an integer question. It's a key question. I'll hold, I'll check for A. Condition number 1 says X is an even number. If X is an even number, it would always be an even. XY would be an even number then. Because one of the even times any number would always give you even. So doesn't matter what a Y is. So condition number 1 tells us that this is a unique condition to answer my question, is xy even number. If I check the condition number 2 properly, which says y is an odd number, now I'm not pretty sure about what an x is. If it happens to be even, then xy is even. If it happens to be odd, then xy would be odd. And now here I have seen a student making a mistake. They take condition number 1 also and mixing it up. Always take the conditions as independent. So there are two possibilities. X becomes even, xy is even. If x is an odd, xy will become odd. So I'm getting a yes and a no, which is not unique. So my condition number 2 alone will not be sufficient. So in this fan, I'm getting my answer as A. I got my answer as C. If I'm jumping quickly, just reading to the solution and not paying attention, indeed, in the going to depth. So this goes as A is the correct answer for this. Let's go for common mistake type B, 4B, that says that, if you're getting A and B as your possible answers quickly, then you should always hold to mark it as D. So there would be again two cases that we have already discussed on this part. Common mistake type 4B talks about consider D. The questions are the same: integers, statistics, probability, inequalities, and absolute values. So D is more likely answer than A or B. And they will definitely frame the questions in such a way that if we feel that A and B are going to be answers very easily, so therein where you have to hold yourself and mark your answers. So if, and also if one of the condition is pretty easy and one is the hard, mark your answer as D. So now let's go and try this question that would be there on the screen, which will actually tell us about how to mark D when possible answers were A and B. So if A and B are positive integers, what is the value of A over B? For me, if I have to get the value of A over B as a ratio or a fraction, I just need the value of A and B. Condition number two is, seems to me 6A equals to 4B, a slight arrangement will give you 2 over 3. My job is done and I'll mark the answer as B and I'll move ahead. This will happen when you have just got 30 seconds or 1 minute time in your exam. You will not pay much attention to this sort of question. If I give you almost 15 minutes to solve this question, you will never ever make a mistake. Right now, we are not talking when you could make mistake. We are talking about what is it or what all is it that can make you or force you to make mistakes. If I give you ample amount of time to solve this question, you'll go very slow. We'll check condition one, condition two, and then we'll make out your answer. But what if you still have 5 questions left and you have got last 3 minutes to solve a question, and this is there on your screen on the real GMAT test day? What you're gonna do? You're just gonna read about this. First equation is a linear equation AB. We know that we cannot solve it. Why we cannot solve it? The reason behind that is it's a two variable. I've just got one equation. Second, directly giving you the answer B, and marked it. So the concern here is this is all happening if we have taken a lot of time at the start to solve certain questions. So I again repeat it: go for variable approach, or the you know the way or the method, the strategies, the process wherein you could save a lot of your time to avoid this mistake. Let's go ahead and solve this question. The first particular step is to modify. There's nothing much to modify in this question. It's A over B. It's A over B. It's an integer question. We have to remember this. We need to find the unique value of this. So, that is also one case. And state number 2 and 3 that we do, it's a two variable question, A and B. Answer looks to be C. If we combine both the situation right away at the start, it says 4A plus 7B is 29 and 6A equals to 4B. If I divide both the sides of second condition by 2, I get A equals to 2B over 3. So I'm not just putting in, I'm just substituting the value of A into it, 4A plus 7B. So I put the value of A from the second condition. I substitute it into the first condition, and I end up getting it as AB 8B plus 21B equals to 87, which I solve. I get B equals to 3. If I get B equals to 3 at the end, plugging in the same value in the second situation, I can end up getting A equals to 2. So it's a pretty sufficient value right now. It's a pretty easy way to consider the fact that both the situations are considered and both the conditions are combined, and we are getting answer is C. But did we check the conditions separately, each condition separately? Right now, if you see 6A equals to 4B, let's solve condition number 2 first. 6A equals to 4B. A over B gets me 2 over 3. It's a unique condition. So condition number 2 alone would be sufficient. Now let's solve condition number 1. It says 4A plus 7B equals to 29. Now bring in your concept of relative primes. 4 and 7 are relative primes. They have a common factor only as 1. So there would be only one ordered pair of A and B that would give us a value of 29 when we plug in that. And that would be 7 times 3 is 21. So we need 8 more. So A could be 2. So A is 2 and B is 3. and that 2 comma 3, that would only give us a value as 29. So now both condition alone are sufficient, and our answer goes as D in this situation. So it is started with C, it was going towards B, but it is ending up at D. So this is wherein you have to pay attention. Okay, now let's talk. This was something which I was actually focusing upon what happens when we go ahead with DS, what happens when we try to solve the questions through conventional methods and all those, and therein where I've told you what all those methods could be that could save a lot of your time and prompt accuracy is maintained. Now let's talk about some small concept that would be considered. If you miss onto it, then it would be definitely counted as a fatal error into the GMAT, because this would be more likely towards PS. And what happens in PS is, we get 5 options, and if I'm solving a particular question, if I'm not getting my answer as one of the answer choices, I still have a time, and I could still dare to go back to the question, reread it, comprehend it again, and solve it to get one of the options from the 5 given options. But what if I'm solving my question and I'm still getting my answer as one of the choices, and that goes wrong? See, I'm not gonna cross check my solution or judge myself on every single solution that I do, and therein where I make mistake, because I have to be very much focused on this sort of things. First is revealed integers, and second one is hidden integers. Revealed integers are the actual numbers that we talk about, like 66 or 100. But hidden integers are, they cannot be further divided into fractions or decimals, and they're always defined by the variables. Now this is something, a theoretical picture of it, but how does it get applied into a real question? Always find a hidden one into the question. Always find a hidden one into the question, I'll say. For example, you have a number 36. You can always prime factorize it as 2 squared times 3 squared. But if I ask you to just factorize it, you can also get it as 6 squared. But that 1 square is a hidden one into it. Will that make a lot of difference? It will definitely make a lot of difference. Let's go on to a question and understand it. There will be a PS question so that we could make out. Question says, if a cube whole to the power of b is 729, where a and b are positive integers, which of the following could be value of b? Now, I know that this is an integer question and I have to actually deal with hidden one as well. I'll start breaking 729. I know 729 is 27 is square. Now, I can write that 27 is 3 cube. So I'm getting it as 3 cube squared. I'm done. Comparing with a cube b, I can easily make out that b is 2 and a is equals to 3. So now, question is asking which of the following could be the value of b. And second, so 2 is a possible answer. And there is an option also which says D, second only. But how about if I see a hidden one into it? Let's say 729 is a cube of 9. So I could write it as 9 cubed to the power 1. That means if I compare it with a cube b, a becomes 9 and b becomes 1. So now my option number 1 and 2 both are possible. Option number 3 is definitely not possible in this. So always find the hidden one. If you miss it, the answer is still there as D, but that would be the wrong answer. So A is the correct answer in this. Let's solve a DS question based on this. If A to the power X and B to the power Y is 144, where A, B, X, and Y are positive integers, then what is the value of A plus B? Condition 1 says that X is greater than Y, and condition 2 says that XY is equals to 8. We'll be solving this through a variable approach. There are four variables involved, which are a, b, x, and y. We have to be very pretty sure about this, that they are the integers. There is one equation involved, which is a to the power x, b to the power y equals to 144. I've got four variables, one equation, I need three more, and that is how my answer should go as E. So if I combine both the situations or both the conditions here together, I end up getting as condition number one says x is greater than y and xy, the product of x and y is 8. The possible chances here is 2, 4, comma 2, wherein x would be 4 and y would be 2. So 4 comma 2 becomes 8. So a plus b. So let's break the 144 into format of 16 times 9. 16 is 2 to the power 4 and 9 is 3 squared. So x is 4, y is 2, 4 is greater than 2. So both of the conditions are satisfied. So a plus b becomes 2 plus 3, which is 5. Now let's talk about the hidden one. What if I consider hidden one here? So 144 can be written as 1 to the power 8 times 144 to the power 1. Just to make x greater than y, we have taken the power of 1 as 8. That makes my a as 1 and b as 144, and if I add those up, I get 145. These are not unique answers. But what if I leave myself only to a plus b equals to 2 plus 3 equals to 5, and I don't consider consider the hidden one into it? I'll simply mark my answer as C here. But this is not sufficient. So E is the correct answer for this. Because if you go alone on this, that it will not work. X is greater than Y, there are a lot of possibilities, and X, Y is 8, there are a lot of possibilities. So this is one point that I have to request you to go again when you go back to this video and look at it. Second is consider the negative numbers. We often don't consider the negative numbers, and that creates a huge trouble. 2 is square and 3 is square. We know that negative number raised to an even power will not make a lot of difference to us. It turns into positive. But what happens if we don't consider it? Let's see into a question and understand it. It would again be a PS question that says A, B, C are integers such a way that A is less than B, which is less than C. And the product of all these three integers, a, b, c, 6 is 6. What is the smallest possible value of a? Let's go ahead and understand the negative numbers into it. If we factor 66 as 2 times 3 times 11, we could easily make out that it's 2 is less than 3, which is less than 11. So the smallest value of a seems to be 2. It can orally be done. You don't even need a pen and a paper to do it. 66, 2, 3, 11, 2 is the minimum. Satisfy a, b less than c. 2 is less than 3, which is less than 11. Mark your answer as 2. Go ahead. But what about the negative number? What if I consider the negative number? How about writing 66 as minus 66 times minus 1 times 1, and it still satisfies the value. Minus 66 is less than minus 1, which is less than 1. So your lowest value would be minus 66, and your A would be minus 66. So the smallest possible value for A here would be minus 66. And I again repeat, when you didn't consider the negative numbers, you were still getting 2, which was already your option. So GMAT always traps such kind of options, always forms such kind of questions. And even in dreams, you cannot even think about what mistake you have made. So this is wherein we have to hold your nerves. First was save the time to avoid the mistakes. Second is hidden integers. Third is negative numbers. The fourth one that we're coming here is consider the irrational numbers. Now, when we consider the irrational numbers, we know square root of 2 raised to 2 would be 2. Square root of 3 raised to 3. Radical sign to the same root again gives us a number. So if I'm breaking 50 as 2 to the power 1 as 5 square, that's okay. But I can also break it as a square root of 2 square, 5 square. I can also take 1 as a hidden 1 to the power 1, and I can write it as 5 root 2 to the square. Root 2 here, or a square root of 2, considered to be an irrational number. Now, what happens if irrational numbers are not considered, and what difference it can make? So let's say we have a DS question which says 1485 is expressed as a to the power of x, b to the power of y, and c to the power of z. Then what is the value of a, b, c? Condition number one directly talks about 1485 is a cube bc. So that says like you already have a power and c is 11 into this. Now if you talk about here, there are six variables involved: a, x, b, y, and c, z, and there is only one equation, so definitely the answer goes as e. But again, when we combine both the conditions together, because if e is the answer, already combine it, don't check for a and b. And see, there is nothing called an integer word or anything mentioned here, so you can directly combine it and go easy on this. Let's break 1485 as a factors and write it as 3 cube 5 to the power 1 and 11 to the power 1. If we compare this with a cube bc, then definitely A would be 3, B would be 5, and C would be 11. So ABC is 3 times 5 times 11. But now 1485 is a revealed integer. Well, how about if I consider irrational numbers into it? And C is already given to us 11, so the only thing we wanted to have was A and B. But now let's say 1485. How about if I write it as 3 cube root of 5 to the power 3? Which is ultimately 5, right? And 11 to the power 1. Or maybe I could write it as 3 times of cube root of 5 to the power 3. I can combine both. And I can take a hidden 1 into it, 1 to the power 1 and 11 to the power 1. Now see, understand, this is wherein, I was talking about. So possible values of ABC goes as 3, 5, 11, or 3 times of cube root 5 times 1 times 11. This is not a unique answer. But what if I don't consider that cube root of 5? Don't consider that irrational number. If that happens, then I would definitely mark my answer as C, but the answer is E. And this is why, it happens, because I've been talking to a lot of students over the consultation calls. And when I talk to them, when I see the solution or when they express the solutions, we often find this error that while checking the solution, we say, oh my God, how can I forget that? I mean, so it was not difficult for anyone to understand. I mean, you guys understand what this cube root 5 is. You know how you could raise it to cube root 5 to the power 3. You can express it in this way. But the concern was, why didn't you do it while solving the question? So the concern is the same thing. You had to make sure that you consider the negative numbers. You consider the hidden one. You take on irrational numbers. Map it into your mind that I have to do it, and then you have to mark your answer. This will save, and this is why I took this into the fatal mistakes. Because see, fatal mistakes could, if you're taking a range of inequalities somewhere less than zero and it was asking for a greater than zero, that is not a fatal mistake, that's a blunder. You need to understand the difference between the word fatal mistakes and the blunder, right? If anything that you make an error onto your concepts that you're learning, if you're considering one as a prime fact number, that's a blunder. It's not a fatal mistake. Fatal mistakes are the hidden mistakes that you not even can think about and you're doing it. So this is why I have taken such kind of topics in fatal mistakes. Let's talk about the hidden integers. We are done with the revealed integers, we're done with negative numbers, one is a hidden and irrationals. Let's talk about the hidden integers. So we know what the revealed integers are. They're the actual numbers, like, example minus 17 or 94. But what are the hidden integers? Let's see a question here. It says the ratio of the number of bolts to the number of nuts produced by a certain factory F is 5 is to 4. So we are dealing with the ratio of B and N. Now, if there are 10 more bolts than nuts produced by F factory, what is the number of bolts produced by factory F? Now, let's talk about, now, so we are dealing with a lot of variables here. There are two predominant variables that this particular question is talking about, which is bolts and nuts. And we have been dealing in terms of ratios. The earlier they have given us the ratio that if the ratio is 5 is to 4 between B and N, And if there happens to be 10 more bolts produced than nuts, what is the total number of bolts produced? We have been given with five options: 30, 35, 40, 45, and 50. The options are pretty close in terms of factor of five. So let's say that the number of bolts were 5k, k being a positive integer taken, and number of nuts are 4k. So this will keep intact our ratio of 5 is to 4. Now we know that if there are 10 more bolts than nuts produce, so for nuts to be equal to bolt, I have to add up 10 to it. So that means 5k is equals to 4k plus 10, or k is equals to 10. Now if I know k is equals to 10, my answer directly goes as 50 and 40. So E is the correct answer. So that k here was the hidden integer. Let's talk about another DS question now. What is the total number of golf clubs that John and Tom have? We're dealing with a total number of golf clubs, so we need a unique number here. And suppose if we assign a variable like John will have a J golf clubs and Tom will have a T golf clubs. So we need to find the value of J plus T. So we're dealing with two variables here, J and T, and we need two equations. So possibly our answer would be C. So if I combine both the conditions right away at the start, I'll save a lot of time of mine. So condition number one and condition number two, if we combine, condition number one says that 80%, John has 80% more golf club than Tom. So if I convert that into an equation, it says John would be equals to has. So that is equals to 80% more. So that's 80% of T plus T. So that's a 1.8 times of T. So J is equals to 1.8 times of T. And condition number two says that Tom has between 11 and 16 golf clubs. It's between 11 and 16. So T is somewhere between 11 and T. Now, the only thing which you have to remember is number of clubs cannot be a decimal value. I cannot hold 11.4 or 22.9 golf clubs. Either it has to be 11, either it has to be 22. So that has to be a pure integer. Now, the best thing that I could do is I can simply put the value. T must be definitely between 12, 13, 14, 15, and 15. That's it. So 11 and 16 doesn't work. If I put T equals to 12, 1.8 into 12 gets me 21.6. That cannot be number of golf club. So if I put T equals to 13, 1.8 times 13 will give me 23.4. You don't need an exact multiplication. You can sense it out. It's 1.8. Definitely, if you put it to 15, that can make it decimal as 0 and you end up at 27. So 27 can be the number of golf club that John has. Now, the Tom had 15 and John has 27. That gets us 42. So this is a unique answer that we combined. So the hidden part was the integers into it. Now let's talk about decimal errors and step error, possibly the one of the error that has been often seen to be made to the conventional approach. And I'll show you the conventional also in this, how this error is being unfortunately made and how to rectify it. So decimal errors are usually into fractions and the decimal questions, and step errors always happens when we assign a variable to x, y, z. Let's talk about this particular one question. A certain company has a department A and B. So there are two departments A and B. 40% of employees in department A are females and 32% of employees in department B are females. If 38% of company employees are females, what is the ratio between the number of employees in department A to department B? We have to find the ratio of number of employees of A and B. We have been given the data for females of A, B, and overall company. Conventional approach talks about assigning a variable. Let's the number of variables in department A is X, department B is Y, and let's talk females in department A is 40% of X, that makes it 0.4X. Females in department B makes it 32% of Y, that makes it 0.32Y. Females in the whole company, so X plus Y will make it 38, that makes it 0.38 times of X plus Y. This is a conventional approach. We are still dealing with X and Y. So now this is wherein we have ended up 0.4x plus 0.32y would be equals to 0.38x plus 0.38y. Now over here, there would be possibility of making a possible decimal error. See, No one is doubting onto your subtraction or addition skills when it comes to decimal, but small silly errors, that is what we call as silly errors. Why it is silly? Because you knew at how to solve but you did it. This is wherein the possibility of decimal error could happen. If not, then we would able to solve this question like 0.02x equals to 0.06y. Multiply both the sides by 100 to make it 2x equals to 6y or x equals to 3y. Now this is wherein if you're getting x equals to 3y, you can again make up a step error. But again at the end, x equals to 3y, I've seen students writing 1 is to 3 on the confusion, but the ratio is still 3 is to 1. Right, so this is there are the two possibilities of the stage wherein in the conventional approach you have a high risk of making an error. But now let's solve it the same question through an IV approach. We're dealing with the percentage, take the number as 100. So you have in a department A employees are 100, department B employees are 100B, and so females in department A would be 40% of 100A, that is 48. Females in department B is 32% of 100B, that is 32B. There is no decimal involved in this now. We are actually getting a numbers 40A, 32B, that's a pure integers. Total employees would be 100A plus 100B. So now 38% of those would be 38A plus 38B. If we make it a equation, we get 40A plus 32B equals to 38. There is no decimal involved in this. So this is an elimination of decimal error. Just rearrange it in terms of A and B. A equals to 3B. A equals to 3B. You already got the ratio of 1, 3 is to 1. So that is it. So this is how you eliminate the decimal and the step error if you go ahead with IV approach, which says that if you're dealing with percentages, take ahead the number is 100. If you're dealing with fractions, go with the LCM method. If dealing with ratios, go with the LCM method. So IV approach versus the conventional approach. IV would always save your time by converting the word into equations quickly, easy to tackle the PS question, practical and applicable in the real test. So again, this is all helping you to save your time to avoid errors. Conventional approach, you would definitely spend more time and therefore your chances of any mistakes, be it a silly or you know blunders, would always increase. And if you're taking those variables a lot like x and y right away from the start of the solution and taking it at the end and then trying to equate it, your chances of making a decimal or a fraction error will always convert. There are a lot of other methods also to solve the previous question, like weighted average and again. But yes, this is what I mean from you. Like, Ravish said right now that we can solve this by weighted average. Yes, Ravish. But again, the concern is the same. You should always have an approach other than the conventional that can save your time. This is what I mean. So I had IV, you have a weighted average. If your job is done, I'm very happy and pleased with it. Let's solve this. One of the questions coming on the screen now, which says n is not equals to 0. A is n% of 1 over B. B is what percent of 1 over A in terms of n. We directly apply the IV approach to the axiom 1, which will help us to understand how do we convert the particular statements into algebraic expression. So, we know that what is something of its multiplication is, has, was, is equals to percentage is 1 over 100. A is n% of 1 over B. So A is equals to n times of 1 over 100 times 1 over B. That gives me a equals to n over 100B. What percent of 1A is B? B is what percent of A, or what percent of 1A is B? So theta times 1 over 100 times 1 over A is equals to B. That means theta is nothing but it is equals to 100 AB. Now I can directly substitute the value of A from here, which is n over 100 times B, which will cancel out 100 and 100, B and B, and I'll be left out with N. My answer goes as C. Simple. Now, if I have to solve this by same question by a conventional approach, there are a lot of variables that would be involved. So if you substitute the numbers like N equals to 10 and B equals to 0.1 in this, A is n%, then you get A equals to 1. Then B, you get 10. and then you make out, you're what you're doing is you're just simply substituting the values, and now you're checking every option. A equals to 10 over 100, 0.1, no. A equals to 10 over 10, that is giving you 1, no. N equals to 10, so that is yes. So first you found those two values, then you have put it into the equation, then you got, and now you've been checking the options. And this is actually taken as a conventional approach solution directly. So avoid such kind of solutions to save your time. Is the correct answer for this though. Now let's go on to quickly to understand what does GMAT does not include, so that you could be very well aware about this. It does not include complex mathematical calculations. You need to be very well understood with this fact. Let's see this PS question. X plus y plus z is not equals to 0. 2x plus 3y, again that is equals to 1 over 3. Then again I have a 4 over 3 things. And then I have to find something here. Solving this is not difficult. But what if we've got 30 seconds? Then expanding this would be difficult in that amount of time. So add up both the equations, because you could see 1 over 3 and 4 over 3. Let's see if you add up all the three equations. 2x plus 3y, 2x minus y. Because if you see the denominators, they're same. So you have to just work out on numerator. We end up at here. So we want to know that 1 plus 4 over 3 plus what would be equals to this. After a quick simplification, we end up here. 3x plus 3y plus 3z over x plus y plus z equals to 5 over 3 plus. Taking 3 common in the numerator, I'll definitely cancel out x plus y plus z from both this and numerator and denominator. I'm been left out with 3 equals to 5 over 3 plus something. We have got the answer. 3 minus 5 over 3, which is 9 minus 5 over 3. 4 over 3 is our answer. So, it does not require complex calculations. Use only the given facts. Don't make things up. Don't assume things that are not given in the original conditions or condition 1 and 2. Let's talk about a question quickly here, please. K is equals to mn and k is a positive integer. Is k a multiple of 6? Don't assume m is already a multiple of 12, n is already a multiple of 4. So now let's go ahead with this. There are three variables that are involved, k, m, and n. There is one equation that is present, k equals to mn. Question is asking, is k a multiple of 6? Most likely answer is going as C. If I combine both this condition, m is a multiple of 12, I can write it as m equals to 12t. N is a multiple of 4, I can write it as 4s. If I combine both the equations, k equals to mn, I'm getting it as 12 times t times 4 times s. Rearranging can get me k equals to 6 times 2t times 4s, or k equals to 6 times 8ts. 6 times, yes, it is a multiple of 6. C is the correct answer. Both the conditions are sufficient. Now, very common mistake that we make. K is equals to mn is a multiple of 12. M is a multiple of 12, so mn would be, it doesn't work. If m is 12 and n is 1, it works. But if m is 12 and n is still 1 over 4, because that is a multiple of 4, then it will not be a multiple of 6. No. So again, make sure that you don't assume what is not given. Talking about math revolution, that we have been established in South Korea in 2001. 90% of our students have scored 49 out of 51, and market share has been 70% so far. GMAT math score goal, we live up to your score goal, what you have right now. 45 pointers, variable approach, and IV approach can help you getting your, you know, more than 48 pointers that you want to have. Uh, Max is a person in charge who has taken care of all this informations. He has been there, working on variable approach for a long time, and now it is beneficial for almost all the students in the world who has been preparing for GMAT, who has taken our course, who has been going through, free sessions from us, from the webinars. And Math Revolution, see, it's a unique approaches. Math skills doesn't matter if you're not from, even if you're from a non-math background, you can easily grab it. Quickness, it gives you an alert of 10 minutes to spare. Accuracy would always be maintained with this. 50-51 strategy is pretty simple. Avoid conventional approach. It's not that you cannot get 50-51 through the conventional approach, but you would require a lot of inputs. So apply the variable approach for DS, IV for PS, your shortcuts, your logics, your confidence, and then get into it. Avoid the fatal errors, avoid the blunders, and you would definitely be par. Math Revolution has recently come up with the live online courses. We've been running with the live consultation calls. So live online, you can get all the details of live online from our websites, and you can directly drop me an email through a GMATClub, or you can directly reach me out onto the website as well. And yeah, so you could reach me out at Puneet at mathrevolution.com. For the more information, you can reach us always at info@mathrevolution.com. With the same verse, thank you so much for your time. You can go back to this video, try solving the questions with conventional approaches first, and then look for the VA to avoid the time break, and also go through the revealed integers, hidden integers, irrational hiddens, and all those things to avoid any errors. With the same words, thank you so much for your time. Have a great day ahead. Goodbye.